Good morning, students. In this video, I will be discussing on message switching and also how to calculate the delay for the message switching. So what is message switching? So in message switching, what happens? Each switch stores the whole message and forwards it to the next switch. So here you can see the subscriber A, that is node A, is sending information to node B. So in the diagram, it is chosen this path. Means this node, what it will do? It consists of three paths, this path, and also this path. But what happens here, the whole message is forwarded into the next switch. So which switch it needs to forward, it is decided by this switch. If I name it as switch 1, switch 2, switch 3, switch 4, like that. So switch 1 has the path to move to the destination via switch 2 or switch 3 or switch 4. So the protocol in the switch 2 will help in deciding which path the message has to be passed. That's what the name. Every switch will take the responsibility to identify which is its next switch, the best switch, or the best path to forward the message. So entire message multiplies to the shared channel, and we are using what is known as store and forward concept. Why we are calling it as store and forward? Because each switch should store the data for some time in order to check the destination address in the header and also to identify which is the next best route. So in order to decide that, it needs to store for some time. That's what we are calling it as store and forward concept. So here every header will contain the source and destination address, because here there is no fixed path. Okay, every switch will decide which is its next best route or next best switch by seeing the destination address only. That's what every message will contain in the header, the destination address, until it reaches the destination. So routing at message switches. Yes, here the routing is not initiated by the source node, means it is not giving the complete path. So it will just forward to the first switch. That switch will take the by seeing the header destination address, it will decide which is its next switch. If this is the next switch, then this switch will have two paths again, either this path or this path. Then it will decide which is the next best path. Like that, each switch will take the responsibility to send it to the next neighboring node. And it is purely connectionless. Yes, because here we are not fixing any path or any route by the source. So each node will identify which is its next neighboring best route, and then it will forward the path or data. So for example, see here, from this node it has come to this node. Think that this node number 2 has chosen node number 5. So node number 5 is having a direct connection to the destination, but this path is somewhat broken. So what happens? Switch 5 will easily can dynamically change the route from switch 5 to next switch, maybe sixth switch. So if there is one more switch here, then it can get a connection to this, and then the data can be forwarded to here. So what I am trying to tell here, that route can be dynamically established if there is any failure in the link of the present route. So dynamically it can choose the path as per its convenience, the best route. So that's what we are saying. The message switching will help in dynamic routing. And moreover, this message switching, there is no what you call that division of data. This message switching works in the application layer. So the entire data will move in terms of messages. There is no packetization or and other division of data. So hope so you understood the concept here. So again I am telling, in message switching, the data is transferred in terms of messages. Each switch will take the responsibility to identify its next switch, the best switch, and then the data is forwarded. So in order to identify which is its next route, then it has to analyze for some time. Thereby we are calling it a store and forward concept, and it is purely connectionless. And moreover, in case if anywhere the route is broken, or if there is any high traffic, then the switch has the capability to dynamically change the path to some other shortest path or best path. Okay, and this is mainly helps in used in telegraphy, means telephone networks. So in this diagram you can see these three messages, message 1, message 2 and message 3 is moving in this direction from node A to node B. So all the messages are moving in the same direction. So in this diagram you can see message 1 is moving in switch 1, switch 2, switch 4, switch 6 and destination, and the message 2 is moving switch 1, then it is changing to switch 3, switch 4, switch 6 and destination. So some other message move in some other direction. So it is left to the protocol to identify which is the best switch and then forwarding the data in that particular route. So now let us see the important thing, how to calculate the delay in message switching. So here you can see I am taking one source node, that is what source have written, and destination node, and in between we have two switches. This is switch 1 and this is switch 2. Okay, now a message is passing from source to destination via switch 1 and switch 2. Think that I am passing the message 1, only one message. That message consists of some data in terms of bits, like it consists of 5 bits. Okay, 0, 1, 0, 1, 0. Example I am telling, it consists of 5 bits. So now what happens here, the source is then here. So the source should transfer the bits sequentially. First bit will go now. So here the time taken to transfer the first bit from source to destination, means it's not destination, source to first node, means for example which is our first bit 0. So the time taken to transfer the first bit from source to switch 1, we call it as propagation time. Okay, here you can see this is what the source, the first bit started, the time taken to transfer the data. Okay, the first bit from source to switch 1, means here I have written, see, here to here, we call it as propagation time. So this time we call it as a tau. Okay, that we are representing the propagation time as tau. Okay, next second bit will transfer, third bit will transfer, fourth bit will transfer, and lastly fifth bit will transfer to the switch 1, means the complete message is transferred because the message consists of 5 bits. So the time taken to transfer all the bits or the complete message to the switch 1, we call it as a transmission time. Okay, here you can see. So this is what the tau, propagation time, where the first bit is received. Next second bit will receive here, third bit will receive, fourth bit, and lastly the fifth bit is received here. That's what the complete message is received from here to here. That we call it as a transmission time. We are representing the capital T. That is known as transmission time. Hope you understood. So the total time or the total delay the message is taken to transfer from source to switch 1 is propagation time plus transmission time. That is nothing but tau plus T. Okay, this is what tau plus T. Now from switch 1 to switch 2, same process, the time taken to transfer the first bit and the time taken to transfer the complete message, again tau plus T. Here you can see, here some time it is waiting, we call it as store and forward. I told now it will wait for some time in the switch 1 in order to decide which is its next switch. So however we have only 2 switches, so it will wait for some time and then the first bit is transferred from switch 1 to switch 2, that we call it as a tau. This time this is known as tau, known as propagation time, and from here to second bit will transfer, like for last bit, this is nothing but T. Tau plus T is the time taken or the total delay that is taken from switch 1 to switch 2. Similarly, from again it will store for some time to identify which is its next route, but next node is the destination node. So this is the time taken to transmit the first bit, that is nothing but tau, this one, and this is the time taken to transmit the complete message, that is the T. So tau plus T. So if you see the complete delay, the time taken or the total delay from source to destination is tau plus T, this tau plus T and this tau plus T, that is 3 tau plus 3 T is the total delay that is taken by the message to transfer from source to destination if there are 2 switches. And if there are 3 switches, then the total delay will be 4 tau plus 4t. And if there are 10 switches, 11 tau plus 11t. So if there are n switches, n plus 1 tau plus n plus t times the total delay that is taken to transfer the message from source to the destination. And you may ask you one question, sir, here the delay is wasted, some time is wasted. Yes, that's what we are calling, this is not the total delay, this is the minimum delay. Minimum delay is this one. Some other time is taken for processing time and queuing time, that other things are there that we are it is very least, so we are neglecting it. Okay, so here I can see minimum delay is 3 tau plus 3t in case if there are 2 switches, and additional queuing delays are possible. Here I have written additional queuing delays are possible at each link, however I am neglecting it. So this is how you need to calculate the delay between the source to destination based upon the number of switches in message switching. Hope you understood. So still in the upcoming videos I will be explaining what is uh, circuit switching and what is packet switching, because totally we have 3 types of switching technologies. One is message switching, the other one is circuit switching, and lastly the packet switching. In packet switching we have again 2 types. One is datagram switching and also virtual circuit switching. So all this we will see in the upcoming videos. Okay, thanks for watching and subscribe for more videos. Bye.